Okay, sorry guys. Can you hear me now? Okay, thank you. So, morning again. So, basically, welcome to the day number 5. We are about to be done with all our lecturing or lecture-related parts. So, for the day number 5, this day would be interesting because we'll be talking about a lot about retail and pricing analytics. And by saying retail and pricing, we will be using those terms interchangeably. So because of the part of pricing, pricing analytics considers two things. So first of all, your business models, as well as modeling overall in terms of econometrical or microeconomical approaches. We will be primarily focusing on theoretical parts, just to give you the sense on how we can set up the prices. But as well, we will be doing some modeling in Excel using solver and data analysis add-ins in Excel. So I hope you guys all got a chance to install those, because we will be having one in class kind of like practice. So you will, first of all, get a chance to see how the process works in Excel when you're using Solver, and then you will get a chance to practice on your own. So at the end of the day, you will have pretty much a good grasp of the different techniques used for setting the prices, as well as you will get a chance to try it out by yourself. So the second part, or the second topic we will be talking about, would be introduction to forecasting and benchmarking. So forecasting will be primarily based on forecasting functions available in Excel, and benchmarking, we will be talking about the process, the actual process, rather than just doing it on our own, because benchmarking is a very broad term. So you guys will see it, and then you will be able to decide what kind of benchmarking is important for your business, as well as what kind of benchmarking you are considering into bringing into your company or organization. I see the question, Eugene. Sorry, I didn't catch where to download add-ins. So I sent an email, I believe, on Tuesday to everyone in the group. There is an announcement made in Moodle. 1 second, just to make sure that that one is being published. Pom, 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 pom. 1 second. Oh, okay. So if we go to announcement section, 1 second, takes a minute or two. Yeah, so all the links are included here, so you guys can see it. Because from my understanding, every time when I post announcement on Moodle, you guys should receive an incoming email to all your mailboxes. I'm talking about probably like your ksc.com. So all links are provided there. Cool. Just to make sure, how many of you guys got a chance to install those add-ins? Just thumb up so I can see it. Okay, so for those of you who haven't installed it, please install it now or during the lecture, or even better, 1 second. Yeah, we will have some time once kind of like the theoretical part is over. So you will have like 10-15 minutes to install it. It's a very quick process, but I won't be focusing and basically showing the process of installation on my computer. Any other questions before we get to the our lecturing part for this day? Okay, cool. So let's get to it. The main objective of pricing analytics and everything pricing related is to getting pricing policy created. So when we're saying pricing policy, we're referring to the ways of how company sets the prices of its products or services based on cost, value, demand, and competition. However, there is another term which coexists at the same time, and sometimes it kind of supplement policies in place. and this term would be pricing strategy. So pricing strategy would be a reference to how company uses pricing to achieve its strategic goals, such as to increase sales volume or increase prices to decrease backlog, etc., etc. So when we're considering pricing strategy, it's more about the ability to understand the long-term business objective, while the pricing policy would be referring to the way you are setting up prices. So what comes first, what comes second? It kind of, again, goes hand in hand, because if you have the strategic goal for your organization, for example, you're interested in acquiring market share of 5% by the end of the year. So you are starting, of course, with pricing policy, because you want to understand the structure of all your costs associated with pricing. So fixed cost, variable cost, sunk cost, other costs. But at the same time, you're working on the pricing strategy. So something you want to make sure that you're achieving, you're trending towards. So strategy in this way would be kind of like your long goal, your game plan, but pricing policy would be the actual mechanism, the actual algorithm, the sets of procedures, the way you will be adjusting your prices on the fly. And because kind of like pricing policy and strategy tend to be different, but they're overlapping at the same time. Those aspects of pricing, so to say, I'm talking about policy and strategy, they're not mutually exclusive. So again, something just to remember, they all come hand in hand. So just to consider it when you will be setting up or working with the pricing in your own companies. If we're talking about pricing policy, like step-by-step guide, first of all, for this particular course, I wanted to focus on pricing policy. So basically the way we are approaching the cost structure, we approaching the overall our calculations in order to set up the overarching price. So then you can, guys, decide whether that price is feasible or it is something that supports your pricing strategy. So pricing policy would be probably the biggest part of our conversation today. So the way that the pricing policy works, kind of like the instruction, we are starting first of all with a pricing objective. Then we are determining market demand. Then we estimating costs, analyzing competitors' pricing models and offers. Then we are selecting pricing method, adjusting that according to our overarching pricing strategy. And once we decide and we are confident that that price works for us and supports pricing strategy, we are selecting the final price, kind of like running the final QA, quality assurance analysis, and then we're using that price in our day-to-day activity. So basically, from now and on, each section of this presentation will be covering a part of this step-by-step guide. But because of, again, this course is not meant to be heavily on coding, I decided to include some examples of how you can build models in Excel. So you guys will get a chance to practice some things on your own, as well as you will be able to get a sense on, okay, I have this data in my organization. I can create this kind of like case, or I have this kind of challenge in my organization. So the two questions I kind of like want you guys to be able to answer upon this course completion is what kind of information I need to have in order to build the model in Excel. And secondly, how can I build that model in Excel? Because the number of techniques used for pricing is literally endless, we will be primarily focusing and practicing three things today. So it would be demand or quantity analysis, then pricing analysis, and then we'll be trying one of pricing techniques in Excel called bundling. But I will get to that later. So bear with me, please. So basically, when we're talking about the pricing objective, kind of like item number one in our overall pricing policy instruction, pricing objectives are considered as goals that guide your business in setting the cost in the product or services to your existing or potential customers. So pricing objectives underpins the pricing process for a product, and it should reflect your company's marketing, financial, strategic, and product goals, as well as the consumer price expectations and the levels of your available stock and production resources. So it supports the idea that you are having a good grasp of financial aspect of your company as well as the product side of your company. And for example, for this course, this section model topic of pricing analytics would be very important for the home assignment number 3, because we will be dealing with primarily analysis of financial results or financial metrics, which we covered briefly yesterday. At the same time, we would need to understand the external environment or the environment we are operating under, because in order for us to identify whether the market is increasing or decreasing, or overall like consumption of our product, we would need to build a very comprehensive demand analysis or using some sort of like external research papers to understand how we can position ourselves, as well as what kind of pricing strategy we need to choose in order to achieve our business or marketing goal. Each pricing objective requires a different price setting strategy in order to successfully achieve your business goals. It requires to have a firm understanding of both product attributes and the market. So basically, choice of your pricing objective doesn't have to last forever. So once you see that, for example, you acquired the desired market share, or you see that there is a dramatic shift on the market. So for example, before COVID-19 and after COVID-19 periods, you can adjust your pricing based on the condition change, as well as based on the interaction with your products, because historically you've been stocking products, I don't know, in your warehouses, but right now it's a perfect time to start selling something because you see that the actual consumption is increasing. So again, the way you and the frequency of your price adjustments, it is something that you will decide based on the market conditions. So the rule of thumb in this case, what I always recommend to follow, it's basically if you've seen that the market share of your or your competitors is changing dramatically, then you need to adjust pricing immediately. But if it is something that you may think about on macro level, but if you think about on micro level, which is something very tactical, you always need to think about your competitors' prices and the way you can address them. So in the long term, they won't be able to steal your market share as well as to steal your customers. So when we're talking about pricing objectives, there are, as far as I remember, 6 main parts covered in this lecture. So we will talk briefly about those. So objective number 1 is survival. So idea is to minimizing variable costs, because you're, as a small company or probably like a startup, you are trying to enter the environment. So your pricing is aimed at survival with the hope for growth in a not for distant future. So your company may use a survival-based pricing objective when it's willing to accept short-term losses for the sake of long-term viability. For example, there is a fierce competition on the market, and you see that the prices of certain competitors were dropped significantly. So in order for you to still stay on the market, you are kind of trying to minimize everything variable cost related in order to make sure that the inventories coming in and coming out. So the cash flow is still happening, but probably not at the highest rate as it was before. Another pricing objective is pricing for profit. So idea is maximizing cash flows or prices for the long-term profitability. So it's kind of like ideal environment because demand and cost for your products are known as well as cost for your competitors' products. So you're trying to set up the prices based on both direct and indirect effects of your profit. So the direct effect in this case will be anything related to the price, which actually covers the cost of production of product production, and therefore the number of the products sold also influences the profit through economies of the scale. So for example, the relative benefit of selling more units. So you know that you need to sell a certain amount of units, but you are pretty flexible on how you can approach it. Because if we are talking about profit margin maximization, so you are maximizing per unit profit margin of a product. So how can you do it? It's basically setting the highest possible price. But if we are talking about, but at the same time reducing any variable cost associated with the cost production. So for example, you may reduce the packaging costs. Or for example, the example I'm seeing currently in Canada because of the dramatic flour production for baking needs. There is a company and they use on their packaging kind of like bags the picture of Robin Hood, and it's kind of like called yellowish design. But because of the such massive demand on the market, they decided to minimize all packaging associated costs. So right now, instead of having kind of like a very yellow, very fancy design with the Robin Hood written on it, they decided to temporarily move to simpler packaging. So it's just a white bag with the company's name on it and basically the product details. So it helps them, first of all, to minimize or to maximize profit margins, but at the same time minimizing variable costs in order to, first of all, increase the number of products they can produce, for example, within a given period of time, let's say on a weekly or a monthly basis. But at the same time, it allows them to meet the demand on the market, so they can supply more and more products without actually stopping their production line because of the lack of the packaging resources. Another variation is the profit maximization. So basically setting the greatest pound amount in profits. So this objective is not necessarily tied to the objective of profit margin maximization, because here we're not necessarily talking about changes in variable costs. It's all about just increasing our profit as much as possible by setting up prices or by adjusting the ways we are treating our clients, basically by other pricing techniques, which we will talk about later. Another objective is a market penetration. So basically, the idea is to gain huge market share rapidly and follow through on future price increases. So who may be potentially using this penetration strategy is someone who can use and operate with low cost in order to enter the market, but that cost will be only associated for the particular moment of time. So technically, you are having a momentum, you're using that momentum in order to stick with that, with the lowest possible price for example, price sensitive audience for considerable amount of time. So you use that price to attract the maximum number of customers, either new customers or take a share from your competitors. And then the only one category of people, if you will think about it, would be price sensitive customers, because the people who are not price sensitive, like customers who purchase luxury goods, they're not really likely be interacting and responding to your price offers. So there are some key watch outs or key considerations needed to be mentioned. So the penetration strategy works well if you're in a position to rapidly gain market share. You can bring down unit costs and purposely lowering your prices very fast and address those changes immediately. But if you want to gain the customers in the long run, having low prices for your products may not be the right strategy, because for keeping your business growing and healthy, um, having low prices is not a viable or not kind of like essential pricing technique. So market penetration would be considerable as something that will help you to lower the entry barriers. But in the long run, again, you will need to change your pricing strategy from market penetration to, for example, maximizing profits, or to other objectives based on the market conditions. So the one technique or one objective I mentioned briefly yesterday was skimming. So the idea is to setting the premium prices for your products. Probably the best example and the closest example would be the prices for Apple production. So every time when the new iPhone launched, the price for that product is relatively high, and then it drops exponentially over the time. So for example, in the first quarter, the price for the most recent iPhone, let's say iPhone 10 or iPhone 11, was $1,400. Then in next 2 months, that price will drop to $1,200. And then in, for example, 3 months, that price will drop to $1,000. Why is it done in that way? Basically, there is a group of people, of customers, who are considered as early adopters. So people who are willing to pay high price in order to have access to premium or to the luxury products. And most of the cases, early adopters are people who have high willingness to pay for products and low interest of waiting for the price change. So early adopters in that case would be people who are interested in technology, in having, testing, and using new iPhone's feature as soon as possible. And basically, skimming is very known technique in everything which has some sorts of urgency, and anything which creates a sense that you need to try it right now because of it is such awesome, it is such cool, and it has some sort of brand value. So Apple, again, would be probably one of the best examples. However, skimming has two things needed to be considered. So first of all, if you have, or if you set up the price of $1,400 as entry, as initial price, right after the product launch, in case of Apple, some of your competitors may start with high prices as well, but that price will be $1,300. And the reason why Apple doesn't necessarily work well or sell a lot through other companies, because of the pricing objective skimming. So, for example, in Northern America, there is a number of partnerships with large mobile providers, like large companies like AT&T, Verizon, Rogers, with whom you can sign up a partnership. So technically, they are purchasing or providing phone for you for cheaper price, but at the same time, you are operating under the same price Apple provides to them, and this price usually is not that different from the price you can see in Apple Store. So just again, something to consider. And this strategy works only when there are sufficient numbers of buyers, or early adopters in Apple's case, who have certain perception of the price or have high willingness to pay. So by saying certain perception about high prices, we are assuming that people consider high price not like not something like brand related directly, but something more like quality related. So something like, okay, I can choose, for example, Huawei, Samsung, and Apple iPhone products. It kind of falls within my price range, but the way I will be considering Apple and Samsung over Huawei is, first of all, the quality and the support I will be getting. Um, for example, from the original manufacturer, or warranty, or any sort of like QA support or software support from them, because Huawei is not doing amazing job on that front. Um, Next objective is product leadership. So essentially, it is the position, ideal position of every company, and sometimes product leadership may be associated with a price scheming, but overall, product leadership, it means that you're maintaining your current performance position. Assuming that you're a leader, you don't do nothing extreme. Overall, you are doing things as you've been doing for a considerable amount of time. So basically, your company or company services or products are affordable for your targeted audiences. You are not charging them very extreme prices, but at the same time, competitors who are willing to lower their prices, they cannot offer the same range of services as your company. So if you consider examples, it might be some huge software CRM or marketing automation companies like Salesforce. Because when you're considering companies like Salesforce versus the HubSpot, Salesforce is perfect solution for corporate companies, for corporate businesses. But because of the number of integration they having with other products, those corporate companies, they cannot go with HubSpot because HubSpot has a smaller list of supported products or third-party supported integrations. So that's why when we're saying about product leadership, we are talking about someone or some companies whose list is of services is the number one across the market and across their competitors. And of course, there are some other objectives. So it may be something like non-for-profit companies that companies who are not necessarily interested in maximizing their profits. They just need to hit certain amount of donations in order to cover the operational expenses. So charity organizations, NGO, non-government organizations would be probably the best example of those. So then we start talking about the second part of our pricing policy guide, called market demand. So market demand is a very interesting topic because we may consider market demand as kind of like very generalized number, very generic number of total goods and services available on the market. But sometimes what we are forgetting to include into market demand estimation is pricing or price sensitivity as well as elasticity. So when we're talking about price sensitivity, we are talking about something basic as consumers' response to your price versus the number of units or services you can sell. So if you look at this graph, we are having basically three main types of elasticity. We're having perfect elasticity, perfect inelastic, or perfectly inelastic elasticity, and then unit elasticity. So perfect elasticity or perfect elastic elasticity means that regardless of the price we will be charging, or basically the price will be stable and the consumption will be just increasing. So basically, regardless of the number of units we want to sell, the price always will remain the same. So it's something that really useful and something which is really required for society. So for example, you may consider at this point of time, like hand sanitizers in certain ways. So the requirement, the market demand for these products is always here, and whatever the price you put, most likely that price will work for you very well. Perfectly inelastic. So there is a very limited um, number of products you can sell. Whew, tough morning. Number of products you can sell, and this number of products is not a number of products possible to be sold. Most likely will not change because of the price adjustment. So I would consider that as some like luxury products. So for example, if you consider cars like Lamborghini and very premium cars, which were made on, for example, old prototypes, 30, 40 years old. So the price tag for those cars is insanely high. So you can sell only 3 or 4 cars because the interest for that particular product probably touches maybe like 4 or 5 people across the globe. So basically, you're whatever the price you decide to charge for that product, you will be able to only sell for 4 cars in a year, for example. And when we're talking about unit elasticity, it's basically the very common for all the remaining products. That means that with higher price or the highest price, you can sell the limited number of your products. But if you start dropping the price, the number of products or services you will be able to sell will be increasing. So basically, when we're talking about perfectly inelastic and perfectly elastic types of elasticity, we are talking about something which has a real and strong demand on the market, but at the same time, limited supply, or something which is positioned in terms of brand that people cannot refuse to cannot refuse to buy from you. Therefore, they stay you as the only one provider of that good or services. But elasticity in terms of like unit elasticity, or that transition from price adjustments to quantity adjustments, works for all remaining products. So every time when you have a number of competitors, your unit elasticity would be the type of elasticity you most likely will be dealing with. So the whole point of, first of all, understanding your total, estimating your total market demand, as well as understanding what kind of pricing elasticity you're dealing with, is to understanding and to estimating the range of acceptable prices, where you can come up with the optimal price for your product, where you will be, first of all, maximizing your margins, but at the same time, you won't be losing your long-term positioning, or you will still be achieving your strategic or objective, or overall marketing objective for any given year. So when we're talking about elasticity, we just need to understand what type of product we are dealing with. And secondly, understanding the range of acceptable prices for that particular product. So this kind of analysis, it can be done only via modeling, because you most likely will be dealing with data which coming either externally, so basically like industry reports, but at the same time you will have to deal with your internal reports, because you will need to reassess your product value, your offer, as well as what kind of prices, or what is your acceptable price range you're willing to play with. So within that range, you can identify the optimal price point for you, as well as to develop the right positioning. So you can leverage that price point moving forward. Any questions at this point? Okay. Okay, sweet. Thank you, guys. So then, when we're talking about market demand, or price elasticity, or quantity elasticity, there are two particular curves we will be dealing with. One would be linear curve, and another one would be power demand curve. So when we're talking about linear demand curve, that means that we can put and characterize the demand for our product in a linear way. So in a sort of way that we can stress out and find the relationship between price and quantity in a linear way, saying something like, okay, if I set the price of $10 per unit, I will be able to say to sell, for example, 20 products. But if I set the price of $1, I will be able to sell 200 products. So that means that there is a linear correlation between the price product and the price quantity. In this case, we will also be dealing with some sort of like a constant, which will be considered as some, for example, seasonal consumption index, and as well as with the actual elasticity for the product. So because of this equation, everything has its particular value. We will talk about that briefly, basically in the exercise in Excel. So the way we can basically characterize the linear demand curve, it's basically the difference, first of all, in pricing points to quantity points. So as it is presented here, so we are seeing the price value of price point of $30, but we are not selling any goods. But when we are changing the price from $30 to $20, we are automatically willing to sell, or we are seeing that we are selling 20 products. So therefore, if we are changing and adjusting our price constantly, we will be able to find the price optimum. So basically, we are seeing that every time when we are changing the price, so the linear demand curve, the slope, is constant, but the elasticity at every given price point, the result will be different, in fact, because when we are dealing with the number of, for example, $20 and 20 products sold, people and our profits will be having one value. But when we are dealing with price of $10 and we are selling 40 products, the revenue for this example will be the same, but in reality those revenues are different. So we just need to understand the overarching linear demand curve, but within that linear demand curve we need to play around with different pricing techniques or pricing methods in order to understand that, okay, we can sell this number of items for this particular price or price range, but do we have flexibility to play within that price range in order to maximize our profits in the long run? And we will talk about that. Another type of demand curve is a power demand curve. So instead of having like a linear expression, so that very steep slope, we are having something like parabolic demand curve. So that means that the elasticity, first of all, the equation for that elasticity is slightly different. So the quantity here would be defined as the coefficient times price to the degree of the price elasticity. So overall, when you put it on the scale and you start estimating the price and quantity or the market demand, so quantity and demand will be used interchangeably because demand on the market for that particular price point, but at the same time, quantity you can sell at that price point would be different. So it becomes more like a parabolic, more like the actual curve rather than just a linear slope. So the equation and the mathematical expression of that kind of relationship will be different. And of course, there is the last type of demand curve called subjective. So when you cannot clearly define the price elasticity for your products, you cannot automatically rely on linear or power demand curve. And the two things which can be only identified is lowest and the highest price. So in Excel, you can basically calculate the demand curve based on the trendline function or trendline feature. And we will talk about it in a moment. But overall, you just need to always be confident and having some information handy. So you can, for example, say that, okay, I have, I can work with the prices of $15 and $20 at the same time. 1 second, just trying to open my file. So basically, you have only the limited number of so you have the maximum price, you know, the highest price and the lowest price. You are able to play around with a bit with flexibility. And again, it's just one of examples, not saying everything like by the book or anything like that. So you're trying to understand and to define that, okay, I'm interested in maximizing my profits, but I also have certain assumptions. So let's say that historically you were able to play, and let me just remove this graph so you guys won't be confused with that one. And by the way, you have the same example available on Moodle. So back to this example. So you were able to experiment with different prices, trying to understand how we can adjust prices and everything else. So you recorded and you're assuming that basically under assumption that you're selling products for $25 per item, you're able to sell 1,000 goods or items, and probably the highest price you ever put for your product was $75. So you at that time you were able to sell 111 items. So this example, which I'm showing you right now, is basically given that you have all the data recorded. So basically you were experimenting with the price, you have your demand recorded, etc. But imagining that you have slightly different situations. So for example, I'm just basically randomly removing several value points. So let's say these three. And then, for example, in this particular month, you have, or moving forward from this point of time, you only able to operate with 400 items for every given month. And you want to calculate the optimal or the best price for your products. So how can you do it? So first of all, you need to put the price and demand on the graph and to understand the kind of relationship. So you need to understand the pricing function. And the easiest way to do it in Excel is basically just to create a chart. 1 second. Similar to that, like as you're seeing right now, but usually I prefer to switch price and having them on the left and basically demand or the number of products on the right. So we're just switching. And again, sometimes you would need to tweak it a bit because you see that there are some basically trend lines appearing right now. But if we go back, you can see the something smooth right now, like this right now. So the way you can work with this graph is basically right-clicking, and then you're just changing the objects of your chart. So 1 second, just not really comfortable working with my version of Excel. 1 moment. But essentially what you're trying to add extra objects. So extra object in this case would be the trend line, which we are talking about right now. So the trend line here, but you want to make sure that you have this trend line available on your chart, similar to the previous example. And for example, if we're talking about previous example, you will get something like this. So at the end of the day, it would be the expression of price per number of quantities sold expressed by y equals 625,000 times x to minus 2 degrees. So then what you do, you basically set up the assumption that, okay, the desired number of goods I'm trying to sell is 400. So then you need to estimate the price point or the desired price point you need to use in order to sell 400 goods. And again, this kind of like the difference between the price of 25 when you sold 1,000 items, and this difference may be really dramatic. So just be careful with that one. But overall, there are a few things we can do. So first of all, we have our price function recorded here. So y equals 625,000 times x to the minus second degree or minus 2 degree. So you basically expressing your price via formula for items you're planning to sell. So bear with me for a second. So it is, if you look at the formula bar here, the same function you're using right now as you have it listed on the timeline. So basically what you are saying, and in terms of references, that we are using the same function as here, where the 625,000 it's considered as a price elasticity, and then, sorry, would be considered as a constant. Then we're using the number of items we are planning to sell or items sold, and then we are just increasing it to our price elasticity. So price elasticity is -2, and therefore we are getting the number of or price point of 391. But is it enough and is it sufficient? That's a very good question. So because of there are like various techniques we can use, and for example, you want to maximize the profit, or for this particular moment of time, you're trying to estimate how, what or how much or how high my price should be in order for me to sell 400 items. Sometimes you may be operating under slightly unrealistic circumstances. So what I'm trying to say that because of your model is not, or the data you have prior to that is not really sufficient. So it's not capturing all the data prior to that. So for example, before 20 pricing point of 25 and anything prior like 10, 11, 12. So you may come up with such small price. So if you want to maximize the revenue, but still operating under the assumption that you need to sell 400 items, and the reason I was asking you to the reason I was asking you to install the solver, that was very simple. The solver can help you to build a very, I would say, very simple, but at the same time, effective model. So as well as in Python or in R, you would need to work a lot in order to adjust your model feed and adjust the model's precision. So basically, you need to set the objective, first of all, for your model, or and in this case, it will be a solver. So we are setting the objective to revenue maximization. So basically, in these two columns, we will be having the formulas, like calculations for our price, calculations for revenue, and then we will be having the actual formula on for revenue. So just to break down the server settings, so we are saying that we want to maximize our revenue. So we are choosing the target cell. Then we are selecting our kind of like method of optimization. So it will be maximization of the revenue. We are flexible with our prices. So we are changing variable cells to our price. So it would be B23. And then we need to add certain constraints. So in this case, if we are changing certain constraints, it would be basically our price. So the lowest range we are willing to take. So for example, in this case, it was 1, but for example, 1 is not realistic. So let's run this model one more time just to see what kind of result we may get if we change the constraint from 1, let's say, to 20. And again, there is no like right or wrong answer. You just need to try it several times in order to assess and to come up with the best possible price for your particular product. You also can play with number of different constraints. So for example, as I was saying before, if we are assuming that the possible or the maximum number of items we can sell is 400, so we can add also additional constraint saying like the number of items we possibly can sell would be, let's say, 400. We just add in that as a constraint as well. And then the method we are using is basically GRG nonlinear. So we are clearly seeing that based on this trend line, that the relationship between the elasticity is not linear, so it's a power elasticity. So therefore, we are choosing nonlinear method. In this case, GRG nonlinear. And then we are running solve. And again, we may come up with the solution relatively fast, and sometimes it might take a while for us to get it. So for example, in this particular case, because we are operating under assumption that we are only having 400 items available to be sold, the solver automatically returns the result. The maximum or the best or optimum price we can put for our product would be $39.52. So again, guys, something to consider because you will be able to recreate it on your end easily. So it shouldn't be that difficult. I see some messages here. X is the price, Y on the graph, X is the price. Again, guys, it's not about just the way you put it, it's the way you play around with the configurations. Because if you tweak it several times, the things, and the thing I hate about all these kind of like a demo things, you need to spend a lot of time just to make sure that everything works smoothly. So just to give you like the sense here that by saying why we are estimating the price, so Y here it stands for price and X should stay for the actual number of quantities sold. If it's misrepresented on the graph, my apologies, but overall, you just need to have the idea so you can rework it on your end. Makes sense? So far, so good. You guys can follow it, not too complicated. Just a thumb up or let me know if questions.
I have a question.
Yep.
Yep. So based on our experiment, at a price of $40, we sold 391.
Yep.
So why, if we want to sell 400, would our price become $3.91? Or I guess is revenue max is a mislabeled item?
Revenue max, you talking about revenue max here or revenue max here?
Yeah, revenue max meaning individual price?
Yeah, so basically, let me just add it to clarify. Revenue max function. Oops, my bad. Ukrainian. So this is a function. And basically the assumptions you are working with your function. And the actual maximum revenue would be here. You're expecting to get. So basically, if you put it in this way, this would be price. This would be items demand, items sold.
And what's the $3.91?
If it brings more clarity. This one was the calculated number based on the price function from here. So you can see it here. It just follows basically the price function as I was developing on this graph. But remember when I was saying that it might slightly mislead you in terms of actual results, because it uses only assumption of particular number of items without actually running a model. So that's why this number will not be necessarily accurate. So the way of calculation you want to stick with, it would be energy nonlinear function. So you can calculate and maximize your revenue via the model we just ran. What is, one second, see more, another question. What is in the 21st row? Basically the difference between, so just to, sorry guys, just to clarify. So basically 21st row contains the data if we make a calculations based on the only equation of price function as we are developing based on the trend line. But if we want to make it even further, we need to make sure that we have the formula in place for our calculations. Make sense? Because right now we talked about the price, but just to step back, we will be also breaking down the way of defining the demand for the products. So far, so good? Any other questions before we move to the second part? Yeah, okay, sweet. Cool. So let's take a step back when we are trying to define the demand curve. So demand curve is slightly different thing because, again, if you think into different, in the way of what kind of information I'm having at this point of time, you will be either articulating with price values or with demand values. So it's either price function or demand function. Basically, if, for example, we have only 2 price points, but we're interested in understanding and to defining the overall demand for the price point of $30, we would do the same things as we've done, but it will be kind of like twisted or basically flipped logic. So why am that? So let's assume that you know that you can sell 500 items for the price of 50. And the same thing applies that you also decided to increase the price a bit to 51 from 50 dollars, and then you were able to sell 490 items. So the revenue calculated as follows, basically the price times demand or the item sold. But what if you're interested in selling, for example, 500 units? So the way it is defined here, we built the graph. So we basically give our trend line or demand equation expression. So basically this expression follows us here. So we put this expression into this cell. So basically, as you guys can see it, we are saying that -10 times price plus 1000 would be the expression or the function for our demand. So if, for example, we are continuing with the idea that we are referring to the price point of $50, it would be the same demand as we're seeing here. But if, let's say, we change it to 49, you see automatically it changes the assumption. So the pattern or the expression we are seeing right now, it will be all based and linked to the demand equation. But what if we want to play with, for example, with the price point of $30 and we want to understand our demand pattern? So that's simple. We are just using the same basically function as we are having for demand equation here. So we are referencing the price point of $30 as it is here, and just making sure that all components of demand equation are included. And therefore, we are including our revenue point, revenue function. So price times demand. So how can we do this? Well, multiple ways again. So we can basically just use the function as we just did for the price curve here, or we can just stick with the formula. But formula, as it is expressed here, it's not always the best way. So what I encourage people to do is basically start with the function of maximizing the revenue. So you have this certain idea of about the number of products or the revenue you're having in mind, so you can calculate retroactively. So the things will be done similarly as it was done here. You're just setting the price for your product. You are assuming that the revenue, or basically the formula for the revenue, is the same, but because why the result of 1000 is here for demand? Because of the formula. So what we're gonna do right now, basically the same thing. So we are going to solver. We have already our objectives and all characteristics populated. So we are setting up the value for the max revenue. And let me just add some more descriptions just to better, just for the sake of clarity, so you guys can follow it. So price, demand, max revenue. So basically, we have all our values and all our functions populated already. So we are saying that the price is unknown for us. We're interested in basically selling 1000 units at the best possible price in order to maximize our revenue. And again, you can guys basically play around with this logic, use and change it as many times as you want. But again, just for the sake of this exercise. So again, we are maximizing our revenue cell, setting it to max objective, changing the variable of the cell. So in this case, we are changing the variable of the price. Then we adding the constraints that the price cannot be less than 0, but the number of, for example, items we can sell at this physical or at this moment of time physically, it's 800. So the same method, you just click solve and see what's going to happen. So this result returns us 50 as our best possible price point for the number of 500. So it was 400. 1 second, let me just rerun it. I clicked the button. So basically 500. So sometimes what you guys may get based on solver function, that sometimes you will get the same result. So that means that either you don't have enough data to make a better decision, or basically adjust your model for the better precision. Does it make sense? You guys follow this? Or it's a bit complex and complicated the way I explained it? Using a nonlinear solver on a 2-point data set is the problem. Yeah, because the data is not sufficient. So you would need to add way more data. This one is, yeah, because this one expression would be like the linear demand. So you will need to add extra points. Yep. Just as an example, I was trying to show when you don't have sufficient volume of the data, the function will be twisted. There is another function you can use for this example if you want, but again, 2 points, you would go with a simplex linear LP, and then you will be just running it. It will return you a different result, but usually it will return exactly the same result. So wherever you want to choose, you see the linearity conditions required by this LP solver are not satisfied, because again, the number of price points and demand points are not sufficient. Following, guys? All good? We can continue. Okay, cool. So again, the application of these kind of methodologies in Excel is limitless. So you can find like endless number of examples based on the like econometrical models in Excel. In a kind of like in the ideal world, you will be dealing with a limited number of data, so something similar like this. And again, those numbers are dummy, so I just wanted to show you how it may work for your particular case. But it all comes to something similar to our segmentation assignment number 1, when you need to decide that, okay, there is a certain sets of metrics, columns, correlations, data available, and you will need to play around, try taking this data, testing this data, and to seeing whether certain price points or certain quantity points make sense for your business. Because again, it's not like the crystal ball. You cannot take it, run it one time, and the same about prediction modeling or machine learning. You would constantly need to reassess your model several times, maybe once in a while, just to see whether your model is still operable or not. So again, this is just an idea on how you can use these kind of functions in your day-to-day work. And again, the number of materials available for Python, for R, for Excel is literally endless. So just spend some time if you're interested in this kind of like modeling, pricing modeling on your own. So you will be able to see and explore those by yourself. Because if we start practicing all these kind of functions in Excel, we won't get much time to even, I believe, cover 6 days of our lectures. So the way we will be progressing from now and forward, I have only one another bundling example, which again is based on dummy data, but that dummy data will make sense to you once we start talking about it. So in this course, I have listed probably, I would say, the most common pricing techniques. So theoretical part as well as the labeling explanations and kind of like use scenarios already available. You guys on your end, you can go and explore the actual techniques used, for example, in Excel, R, and Python by yourself. Modeling is not the part of this course. The part of this course is the analysis. So you having a task, you need to, for example, identify the optimal price point or understand the market demand. Here you go, you plug and play. So it's all about adaptivity as well as the number of hours in and hours out. So in order not to waste your time being focusing too much on models and not facing actual business problems, I want you guys to focus on understanding the overall system, so then you can understand the environment you're operating under, pick the right model, and work with that model on your own. So for our assignment and assignment 3, I'm talking about home assignments, you won't need to do any modeling. It would be all per calculation and your judgment. So again, there would be no right or wrong answer. It all comes to understanding on, okay, I tried this option, and this option. So out of those 3 options, option 1 is the best because it grants me the highest return on investment or return on marketing spend, as well as the value of net present value for this scenario or for this alternative is the highest. Are we cool with that? Are you guys okay with that? No problem. So modeling is not really an issue. Let's go and get to the actual work. Sweet. Glad to hear. Because again, some people think about marketing analytics as just models and only models. No, in fact, it's way broader term. You need to take into equation the external conditions, circumstances of your particular product. So you're assessing the properties of your product based not only on the product and demand side, but as well as in certain properties in order to have all the communications and all channel optimizations optimized and basically monitored well enough. So I'm not gonna come back to that part. So we covered 2 main aspects, price and demand curve estimations or elasticities. So for now, we are basically halfway through our pricing analytics lecture. So okay, let's spend, yeah, we still have some time. So gonna cover some other slides, then we will have a short break, and then we will come back to our next exercise. So then you guys will get a chance to practice some things on your own. So let's get to it. So remember when I was talking about cost and types of cost yesterday, I was saying that there is like enormous number of different types of costs you may heard about or you heard a lot. But again, it all comes to the purpose and to the case or scenario you're operating under assumption of. So basically for this course, I'm just expecting you guys to know these top 4-5 costs. Costs of marketing and selling, yeah, you may hear about it a lot, but for your assignments and for everything else, as far as you understand the difference between fixed cost, variable costs, and the way they are defined and somehow correlated, that's fine. That should be more than enough. Because again, it will be a part of our conversation and calculations for coming assignments. So another type of the curve which we may talk about, it would be experience curve, or basically diagrammic representation of inverse relationship between the total value added costs of a product and the company experience in manufacturing and marketing it. So in other words, basically the more items you produce, the lower price of your item becomes. Because initially, if you're talking about manufacturing, every single machine has its own limitation. So for you, sometimes it is either because of the number of materials each machine requires, the production cycle is either to produce, let's say, 1,000 of items. At the end, price will be, for example, let's say $20 per item. So 1,000 items per at $20 per item, rather than dealing with, for example, 100 items production at the time, because it will somehow reflect the price of $35. And the reason for that is simple. Well, you are fully managing the variable costs, the price of associated directly with the production. But what you have a little effect on is a fixed cost. And sometimes those fixed costs and variable costs, they are overlapping. So think about that in the next way. So I know that some companies, they have some sort of like a setup or connection fee. So you need to pay, or the licenses, you need to pay per one machine, or some sort of like maintenance fee per machine. So here's the question. If you have one machine which is operating not at the 100% of its production capacity, you pay the same fee over and over again. Let's say it's $35. So when you produce, let's say, 100 items, but the maximum capacity you can produce on that machine is 1,000 items, the price or that maintenance fee of $35 comes into the price of the production of that 100 items. But then when you're producing 1,000 items, $35 will be chopped into price of every product. Therefore, the price overall for 1,000 product will be lower than for 100 product. Just something to consider in the future. So again, there are some handful functions on how we can maximize and model our costs, and the profit maximization in Excel basically is just the way I showed you. So I just put some instructions. If you guys want, you can play in your spare time. But again, you're not limited to those. Just one thing to consider, remember about the solver method. If you've seen that it is non-linear, so it's not like a steep slope, you are dealing with non-linear GRG model. If it's very steep and you have enough price points to say that it is linear, and the model the solver allows you to use linear simplex lin or an ln function or method, then you can use it. But for majority of cases, you will be barely dealing with linear functions. To be honest, I don't remember the full explanation of abbreviation. It's something with gradient regression granularity, as far as I remember. You can look it up in Google. I just basically the way I've memorized them is linear, nonlinear, evolutionary. Yeah, Google knows everything in these days. Then another topic I wanted to cover briefly, it's effect of complementary products. So think it the next way. When you're purchasing, let's say, printer from the store, there are three main types of printers, but the ones we are most dealing with is either laser printer. So basically there's like a huge drum, the cartridge with the ink in it, or the ink printer. Basically, you need to buy the sets of probably like 6 or from 3 to 6 different cartridges. So each cartridge contains an ink in it. So the problem is with selling and advertising the sales of ink cartridges is their price. Because when you're selling ink cartridges together with ink printers, it's either to sell them together because the cost of packaging as well as any sort of transportation costs will be automatically low. Essentially, you just plugged in your ink cartridges, somehow wrap them inside the printer, and that's it. It's good to go. But when you're selling ink cartridges outside of the printer, the packaging becomes different. So therefore, it is affecting the price of ink cartridges separately from the printer. So basically, when we're talking about complementary good, it's a good which is related to associated or pair good. So in this particular situation, the demand for one good printers also generates demand for other good, the ink cartridges. So basically, good A is a printer and good B is or are other inks. Make sense? Ink cartridges. Okay, sweet. So again, there are some ways of using and estimating the effects of complementary goods in Excel. It's a similar method. In this time, you'll be dealing with profitability, and the assumptions pretty much will be the same. And I mean the model specifications. So again, most of the cases, it's nonlinear function. 1 second. Okay, guys, let's go for a 10-minute break, and then we will have another example, and then you will get some time to practice. So 10-minute break, back at 4 o'clock. Okay, folks, back to work. So thumb up if you're at your desk so I can see it. If we're waiting for any more people, any other people, cool. Yep, sweet. So basically, another main topic of first of all designing pricing policy is competitor pricing analysis. So basically, it's just the understanding on what your competitors are doing in order to understand and to have some sort of strategy to first of all reflect the efforts and therefore the efforts on how you address any changes they may or may not do on their end. So basically, the competitor pricing analysis has some sort of rules regards to implementation. So these kind of rules or the implementations instructions may not be directly relevant to your business. So I try to kind of like combine information from different sources in order to have like a very explicit and very in-depth instruction guide so you guys can use. But overall, it all comes to understanding and determining the quality of your data. So kind of like criteria you are using for your data in order to say that, okay, data is constantly extracted from certain data sources. Data gets delivered to your database systems or to your mailbox at the given moment of time. You having the right depth on comparison or data granularity is desired and meets all your demands, as well as the expectations to actual delivery ratio is consistent. So for example, you're expecting to work with a certain vendor or you're working with a certain team, either internal or external, they send you certain data dumps or certain reports, but those reports may not be necessarily reflecting your current needs or demands. So example, let's say that you're interested in data that covers your current competitors' pricing. For example, any sort of price adjustments made by your competitors for the last week, and you're working with some sort of third-party agency who does that for you. But if you're seeing that they're not covering all competitors or all of your products you're interested in, it automatically affects the quality of your data, the quality of your analysis. So just to make sure that, first of all, there is some sort of methodology or the list of metrics and granularities you want to check. And you also have a certain margin of errors or just overall your appetite of errors is defined in a certain way. So for example, because of the pricing in the modern world is dynamic. So it's very rare than you're having a team and they go and check things manually. So most likely you have some sort of like automated solution, which helps you to do it. For example, if you're talking about paid media, it may be tools like Pathmatic. So in the Pathmatic, you can generate those reports and, for example, have it delivered to your mailbox along with examples of creatives. But because of the frequency of the updates made in the Pathmatic, the actual creatives, the assets like banners, social posts on social media, etc., they all get refreshed with, for example, just making things up, with daily frequency. But you're interested, let's say, in hourly or, for example, frequency of every 30 minutes. So that frequency, your desired versus the actual, is not actually met. So in order for you to stay effective on that front, you need to take the consideration that, okay, this price may not be accurate at the given moment of time as of now, because it is something simple as technical limitations or technical stock limitations. So you would need to keep that things in mind when you determine the quality of the data as well as the analysis. Next, you would need to also determine the data parameters. So basically, things or data you are most likely to be collecting and analyzing, or the data that may not be necessarily reflecting prices or the practices, but it will show you some sort of like a direction. So for example, price index. Even though that you know that the prices for these products, group of products, doesn't change a lot overall, but you see that the average price for this group of product has increased based on the price index comparing for this year versus last year. It also can make you think about certain conclusions you can make based on that data, as well as price indexes or used by external companies or by government agencies. So you can compare the prices not within the bucket of your products. So if we're talking about the retail, I believe many of you heard about Borscht index. So basically the sets, it is index based on the ingredients needed to make Ukrainian borscht, Ukrainian soup. So it is the index contains 5 or 6 different ingredients, and it tracks the prices and a kind of like affordability of actual salaries of the population versus versus the actual prices for each ingredient given. And if the price index, just wanted to say another example, thank you. So you can compare those levels of affordability by population by just saying that that index is increasing or decreasing. So you may not be able to see it on a tactical level, but when you're looking on a strategical level or at the higher granularity, so weekly ranges versus monthly ranges versus yearly ranges, you will be able to spot the changes in the indexes. And the same applies for the McDonald's burger index, because you may think about your supply chain for your particular type of the restaurant as something with very steady prices, but at the same time, if you think, or if you're running some sort of like a franchisee business or the business which has multiple locations, you may use one single unique index which will be showing, again, affordability per given location. So McDonald's burger index is one of those. So McDonald's burger index, or just McDonald's index, I've heard many different names for that one. Big Mac, thank you. Big Mac index. So the index value, for example, in Ukraine will be different than in the United States, and it will kind of imply the number of different factors, which all will come together, but all of them will be related to local supply prices and local supply chain prices and local delivery prices and the production cost prices, rather than just having something very fixed for all of the locations. So it just gives you a very good base for comparison. Another one, it's competitors categorization. So because of the nature of competition, you may define your competitors and categorize them in primarily 3 categories. So first one is basically primary category. So direct competitors who pursue the same buyer category or exactly the same targeted audience, which you are trying to achieve or to acquire. The secondary, it's basically competitors who focus on upscale, downscale versions of retailer assortment. So basically the products or the flexibility in the product offering, whether you have some sort of like a tiered approach. So for example, you operate in a software as a software business. So you have, let's say, the list of 10 supported products which come in the package. But for example, your competitor may be focusing not, let's say that if you're comparing HubSpot and Salesforce, HubSpot main purpose was marketing automation, and then kind of like a CRM or vice versa, it doesn't matter for us. But overall, they decided to keep the core of their business as a marketing operation tool, but then extend to the CRM. Salesforce at its core was always about CRM, and then they decided to extend to the marketing automation. So it's a kind of this kind of relationship between competitors or the secondary type of competitors, and to tertiary. So companies selling products which are indirectly relevant to those of the retailer. So I usually referring to anything related to your assortment, not directly. So for example, you are selling Coke or some sort of like a fast food products. So you have, let's say, the price composition of your cup, straw, and the Coke in it. So basically, you may consider everyone be your competitor who operates in selling not the Coke by Fanta or by Sprite, because it is technically the same audience. Technically, it is a primary competitor who is targeting your audience. If we are talking about like overall fast food business or food chain, but what if your audience has the preference to a particular product, so Coke, and they're not interested in Fanta or Sprite whatsoever? Or if they're interested in the particular design of the cup, so that design makes them to stick with, for example, Starbucks product or services or offerings over, for example, McDonald's coffee. So again, just something to think of. And basically, competitor pricing analysis ends not only, runs not only by humans, as I mentioned before, but with machine-based pricing tools. So again, it's the best way and the best thing to have when it's possible and when it's available. Because again, right now or nowadays, our world or world around us is all about digitalization. And making or analyzing all the information in old-fashioned way, just going and collecting all the data manually, yeah, if it's possible to be automated somehow, it's better, better to do it in certain way by having some sort of like automated tools or tools which are able to extract the data from multiple websites and then provide you as some sort of like a report. So I just mentioned Pasmatic is one possible tool for analyzing market advertising, especially very useful for retail because you can get the sense of the prices for all of your competitors, either for the product category or by company and the company sets of sections of the products. So another point is track competitors' online activity. So because of, again, these days all work is about digitalization, you can easily go and check product descriptions, visual presentations, social media activities, any sort of information which may help you to facilitate the process of, first of all, process of conversion or to encouragement of your target audience to buy products from you when we are talking about retail based on the practices you competitors are doing right now. So for example, you see that there is an update in product packages or product packaging for one particular item from your competitors. So it is worth asking a question, why are they doing that? Is it because of analysis they ran into it, or just the company decided to launch a rebranding? So those question matters. But remember when I was saying that we are trying to facilitate the loop of positive customer experience. So the customer support, customer interactions are crucial in that kind of like exchange model. You need to make sure that you're also tracking any sort of customer support and feedback options available or at the deployment of your competitor, as well as the way they're responding to any questions online, either on social media or on forums. So are they running some sort of sentiment analysis? Are there any chatbots available on, for example, on their social media, or some sort of like a Telegram chatbots, so they can answer some questions related to the product availability, pricing discounts, etc., etc., etc. So basically, once you have all these points covered, you ideally should have some sort of document where you track all these changes. And again, you may use this this kind of like a framework as overall as a document for your internal use, or you can use it as a framework. So having the sets of data being pulled into something which will automatically generate you report, which you will be revising once, for example, in a week, in order to understand whether there are any massive changes going on, etc., etc. The best way to do it is basically to have large monthly report, large quarterly report, and some sort of like ongoing or recurring weekly reports. Daily reports not ideal, but again, it all depends on the business. If it's like a fast-pacing, high-velocity retail business, yeah, you would need to do it. But if it's something that has a certain demand, certain elasticity, so then weekly might be your case. So again, it all depends on your type of the business model as well as the type of product you're trying to sell. Any questions at this point before we progress to another part of the lecture? Okay, cool. So enough with frameworks for now. Let's talk more about price bundling strategies. So remember when I was saying that sometimes it is cheaper to sell several products at the same time, kind of like a complementary good or goods. So price bundling strategy or price bundling method is one of those. So basically you're offering several products or services for the sale as one combined product or the service package. And the reason why this is important, I would say it's first of all, the good way to optimize your variable costs or any costs associated with advertising and the promotion of your product, as well as the packaging and shipping or delivery costs. So for price bundling strategy, the main idea is to extract the maximum value of customer surplus for the company. So customer surplus would be the difference between price that the customers are willing to pay and the price they're in fact paying. So we can maximize producer surplus. And in order not to be really confusing, let me just put it in a bit simpler way. So basically, customer surplus, it would be just the feeling, the idea you are getting value from based on the existing price. So for example, in your mind, I'm considering this pen has a value of $1. If I'm getting this pen for 75 cents, either because of my strong beliefs or because of I looked the price somewhere on a different website and I know that the actual price is $1, but I'm buying it for $75 for 75 cents. That's a very cool deal. So that means that I'm maximizing my consumer surplus. But what in fact is a consumer surplus and how it works? It's not only about like small items like pants or any sort of like the physical goods. No, it works also for companies for you. And the reason for that is simple. So for example, we are picking a very easy examples of Disney trips to Disneyland. So you may be assuming that the price for single admission ticket into Disneyland is worth, let's say, $300 because of the number of different attractions, the number of fun you will be having, etc., etc. But in fact, if, for example, you see the actual price, the admission ticket, or the price for air flight to Disneyland is cheaper than your expectation, therefore, you're having an idea that overall it should cost $300, it's well justified price, but you have some certain discount for that, you paying $100, $200 is your consumer surplus. But businesses are interested in knowing, learning, and applying how to turn consumer surplus into producer surplus, which makes us wonder about some things or some topics, pricing ethics. Again, this is not covered in this discourse because pricing ethics, it's something which occasionally hard to define based on the current legislation in any given country. But again, there are like tons of topics on that front. So it's up to you and your business to decide what is ethical or not ethical to do. But for example, in this case, we are saying that airline knows that, for example, during school break times or in summer, parents are more likely to take a vacation to take their kids and fly to Disneyland. So using the regular price for ticket, which would be maybe, let's say we're just making things up, $100, they basically skyrocketing their prices to $300 because they know that there are no other alternatives and the people are willing to pay $300. So instead of now, as a customer, instead of having a consumer value for myself of $200, that value of $200 is extracted by the company. So those $200 go from my pocket into company's pocket because of factors like natural monopoly or some sort of like a cartel agreement on the market, or because of some behavioral based pricing. So again, something to consider. Pricing and bundling methods are different, but before actually talking about them, let's first of all talk briefly about types of price bundling. So then we can dive deeper into example. 1 second, seeing the question. Goodwill option of your business exists somewhat in the consumer surplus. Trying to take it all can be dangerous to your long-term success. Yeah, that's basically the limitation or the problem with the consumer surplus, and we will cover that briefly. But good point, Kenneth. Thank you. So there are several different types of price bundling. So per bundling, when you can purchase only a bundle or nothing. So let's think of it as, for example, we are a business which sells printer and ink cartridges together, and we don't sell them separately. So one example, joint bundling. So you have a subcategory of per bundling in which the two products are offered together for one bundle price. So buy two products for the price of one. Leather bundling is a subcategory of per bundling in which a leather product is offered for discount if purchased with non-leather product or accessory or other item. So for leather bundling, in this case, it would be something like you buying this product and at the same time you're getting a, let's say, 20% discount for a supplementary product. Again, back to our printer and ink cartridges examples. You buying a printer for a fixed price, but ink cartridges prices may be 50, 20, 30, 40% lower from the base price. Mixed leader bundling is a variant of leader bundling, which the added possibility of buying the leader product on its own. So again, just a kind of like a variation of how you can purchase the things in the bundle. And then mixed bundling occurs when consumers are offered the choice between purchasing the entire bundle or one of the separate parts of the bundle. And in fact, it's probably the most common example of purchasing items in businesses like McDonald's, Burger King, or anything where you have the combinations or bundles of your products options, where you are willing to pay different prices. So in fact, we can try this thing in Excel. So the methodology here will be slightly different. So let me just remove some things. And again, you should have this example available on Moodle, so you can see it on your own. So just to take kind of like a step back and explain what was happening here, or just to kind of like have some sort of like a background story. So let's assume that you, for let's say 3 months, you were running a survey. So you're about to launch a new store or new restaurant in your particular area, and you were interested in understanding what kind of prices I need to charge for my particular type of business. So let's assume that you're having some sort of like a new McDonald's restaurant opening anytime soon, and you have a question. Okay, so what kind of prices I need to set in place in order to maximize my profits, but at the same time selling those items above the profitability point. So I will be extracting consumer surplus effectively, in fact, not hurting the customers, but at the same time maximizing my revenues. So you collected the number of survey participant responders, asking them very simple question like, okay, how much money are you willing to pay for one burger, one cola, and one fries separately? And again, it's just a very basic example. So you collected the responders responses of 77 responders. You just organize it in a certain way. So then you realize that, okay, because I have 3 types of products, burger, cola, and fries, that means I approximately have 7 different combinations I can offer to my clients. So option 1, so basically here I call them as a product bundles. So it would be just a product bundle option or version 1, 2, 3, 4, 7, and then the actual descriptions here. So I basically calculated that we may be offering just a burger, just a cola, just fries. But then we may be offering the actual bundles, like combo of burger plus cola, combo of burger plus fries. Then it would be just a combination of cola plus fries, because we already have it already here with burger and fries. And then the combination of all 3 products, burger, cola, and fries. So I'm interested in maximizing surplus. So I'm interested in setting the price which is not too high above consumers' expectations, but at the same time, the price which will make sense for myself. So I basically included here, and again, this is kind of like a framework just to give you the sense of how it can be done, that I'm interested in maximizing surplus for my consumers, as well as to understanding when or how many purchases may technically occur if consumers, based on their responses, on their data, comparing their responses to the actual prices when they're in store, we'll be seeing that they like original assumptions will be overweighting my offers. So let's say that I'm interested in setting price for burger and cola less or lower than burger plus cola. So for example, the price for burger and cola would not be $2 and 10 cents, but it would be $2. Therefore, for example, I'm just adding here burger and cola together. 210, but I'm setting the price of here, let's say $2. So automatically the surplus for consumers becomes positive, and we can calculate it easily, basically based on whatever assumptions we want to put here. So this calculation is done in the way that we are interested, first of all, in tracking the frequency of sales happening for each of those product bundles. So basically, if we are seeing that people don't buy any product bundles, it's equal to 0. This is just a count if function just to extract what kind of bundle or what kind of purchases were occurring, and then the number of options available. So then in this cell, total, let's put it as a total revenue so you guys can follow. We're having the sum of all possible revenues. So basically, if we're seeing that max send and we know that someone purchase it. So we're just assuming that the number of purchases, and the overall formula works in our favor. So the revenue we're expecting to see is just $2. So let me just simply drag this formula so you guys can get a sense on, first of all, how all these differences and surpluses are calculated. And secondly, what can we do moving forward? So let's say that you were able to create the formula, create and calculate the surpluses and everything else. So you see that there are some numbers related to the revenue numbers and everything else, but we're interested in maximizing the profits. So the idea is to maximize the profit, but at the same time, setting the possible or the only right prices, for the sets of products to maximize consumer surplus. Function in solver this time would be evolutionary because we have multiple steps, calculations, and problems involved in this process. So basically, we cannot smooth or adjust our data at the given point based on the survey results. So that's why this method this time would be evolutionary. So the assumptions basically the same as always. We are trying to set our total revenue to maximizing our revenue. We are interested in changing values for our prices because again, we don't know them. We can play around with certain constraints. So for example, I'm interested in all of these prices not to be higher than, let's say, $20. You can also set them separately. So set something like, okay, price for example, for burger and cola combo won't be higher than the sum of these two products. Yeah, there are like tons of different options you can play around, but there is only one big difference you need to just 1 second. To be clear, some of these bundles only have one item contained. Yes, that's correct. So you're also considering the option of people who also will be buying just a burger. They're just interested in purchasing burgers. So that also would be considered as a bundle in this model. So one thing you need to consider when you're running this type of model, this model requires some time to identify the best possible value or the most optimal value. So when you go to options, you need to set up the solving limits, especially max time you're expecting this model to be run for, let's say, 100 seconds in order to identify the best possible solution. In other words, the more time you have, the more accurate model you will get. Set it up for 60 seconds, 1 minute, and then I'm just going to run it. So let's see what's going to happen. Based on your example, I believe it was set probably for 360 seconds, but maybe I tweaked some things yesterday. I don't remember, to be honest, because I was playing around just making sure that everything works smoothly. But yeah, you can set it up to 3,600 seconds, which would be roughly accountable for hour. And then over probably like 35, 40 minutes, you will get the best answer. But if not, the Excel will be trying to calculate the best possible answer during that time. However, don't think that you cannot terminate the process on your end. So because of now Excel kind of like trying to process all this data, all these assumptions, and to come up with max possible value for the given 30 seconds. Oh, I believe model has been finalized. 1 second, not seen. I can clearly say that there is a window, but I cannot see where is that. Just give me 1 moment. Okay, so that's still running. One second, guys. I lost you for a second. Okay, that's better. So basically, the model is, I believe, is about be to be done. So as you can see, the prices has been updated, and I'm not quite sure if it's still running or not, but let's assume that it is. So again, this is just an example on how you can play with this data. Well, like some things to consider always. You always need to keep in mind people who are interested only in one type of product. So it's not, in fact, a bundle like burger, but we still should consider that when we are calculating the expected consumer surplus. So let me just terminate this model so we can just refer to this value. Yeah, I believe it's just my Excel frozen. But anyhow, you got the idea of how the process is working. I think, okay, some question. I think I will start a separate business selling a Coke to number 36. Number 36, you're talking about the participant. 36. Yeah, $28. Yeah, good guy. I agree. So, do you guys want to practice it a bit? Because there is a very simple example and it should be very fast on your end. Just thumb up so I can see it. Okay, what about the rest? I see only 3 thumbs ups. Afraid? Needs more instructions? Not clear? Okay, see some. So if you guys open, okay, let me just terminate this process. Okay, finally, I can see it. Okay, so yeah, just the way it's calculated is as follows. So you guys should have, maybe someone will share the screen and we will do it together. Nope. First of all, you guys will all start alone, and then maybe we will try to go through it together. So first of all, there is a file on model available under material section. One second, just I believe I need to relog in. So day 5, I believe it's in class practices and it calls student spreadsheet. Just one second. So please download that one so we can practice it. Just opening with you together. In class task, day 5, student spreadsheet. That's the name of the file you guys need to download and open. So I'm just copying, pasting, so you can refer to it. So basically, I will be opening that file with you together. So just to go through like the basic instructions. So I just try to pick the most basic example. So at the same time, not to be that massive as, for example, my burger, Coke, and fries example. So first of all, are there any issues with having solver add-in installed on your machine before we start working on this? I just wanted to make sure. No issues, thumb up. Issues, just type it in the chat menu or in the chat bar. Okay, Max, what kind of problems you're having on your end? Mistake occur. Okay, so then, let me just quickly think. Yeah, it probably would require Windows or Excel reinstallation then. So don't worry about that. Think about just reinstalling Excel maybe today or tonight. So then you will be able to accomplish this task or try it out at home. For the rest of you guys, so do you have this spreadsheet open? If you have, please, I believe, so right now it's what time? It's 4:42 and we have how much time left? 4:42. Yeah, we do have some time. So let's focus on another 20 minutes to read in the case. Again, it's very small. And again, guys, giving you the heads up immediately. So all the formulas, everything is populated. You probably need to add some columns here and come up with some rationals. Then tweak your solver model and just to run it. So I believe 20 minutes just to create like the initial scheme would be more than enough. Then we can have like a brief conversation on how it's progressing. And then we will try to finish the model, maybe based on one machine, or maybe you will be interested in finishing that at home. So next 20 minutes, trying to create a schema, the all calculations, the formulas. And if you kind of like went ahead with that, feel free to proceed with model.